Hello again. We are now in chapter 7 of the book where we start looking at machine learning. And for starters, let's look quickly at what a model is for supervised machine learning. Just to remind you, we have two kinds of supervised learning that we're looking at. One of them is called classification, where we have different features being fed into a model, and the model needs to decide what category or what class those features belong for a particular set of values of the features. So the classic example are three types of iris, and if we measure the leaves of the flower or the plant, we will can train a model to decide which type of iris it is. The other type of supervised learning is called regression, where we have inputs and we have to output a number in a certain range. So for example, we have all kinds of features that describe an apartment or a house, the location, the square footage, number of bedrooms, etc., etc. And we need to predict or figure out what is the market value of the house based on examples that we have in dataset. So what we do in this chapter, we are trying to look at models that have a lot of features and see if we can find a subset of the features that is a better way for the model to learn, because some of the features could have noise, or they may be irrelevant and they actually degrade the learning process of the model. And we want to find the best subset of features, the smallest subset possible also, to train the model with. So genetic algorithm is one way to do that, and we can look at the two programs that we have here. The first of them has to do with solving the Friedman problem. So let's look quickly at the Friedman problem itself. It is an artificial data set where it's a regression data set. So there are inputs and there are outputs, but what we can see here is that the first 5 features that are being used are useful, and the rest of them are not useful. So they are just noisy. So if we go for features between 1 and 15, we can see that if you just look at one feature and try to use that, then it's not so great. But as we add more features to it, we can get better results. Basically, our error, for the prediction error of the dataset, goes down and down and down. But after 5, when we keep adding the noisy features that come after the 5, then it actually degrades the performance. So the idea is to give the genetic algorithm this data set of 15 features and tell it, find the subset of the good features and see if it actually can identify that the only good features are the first 5 and the rest of them are noise and garbage. So this is the first program here, and if you run it, it basically tries different combinations of the features, and every time it trains a model and evaluates the model and try to find the best model that it can find, and therefore the best subset of features. So we'll give it some time to finish. And what we can see here is that indeed the subset that it found was the first 5 features, and all the other features it would not select. And this is the best fitness that it could find. Let's move to a more real data set, because this was an artificial one, and it is called the Zoo data set, and we can look at it here. It is offered by the UCI, which has a collection of data sets. And the idea here, we have all kind of animals, and the features of these animals are, do they have hair, do they have feathers, eggs, etc. And we need to decide which type of animal it is. There are several groups of animals that we need to classify the animal into based on those features. So this is actually a classification problem. And if we go here and back to the code, if you run the zoo problem, what it does here is it selects all the features and it trains a model with all the features and checks the performance of the model. And if we do that, we'll find out that the performance of this model is accuracy of about 91%, 90.999. So 91% accuracy when all the features are being selected. The one means that the feature is selected. We're going to see if we can select less features and if we can improve the accuracy. So the Solve Zoo is going to attempt that. And we run it. And you can see that already the accuracy is better than the 91% that we have found before. And it actually goes to the point of more than 96%. Now, what the algorithm does, it also gives some reward. So most of this reward is the accuracy, but there is some reward for the number of features that you select. And this is used like as a tiebreaker. For example, you can see that the best solution has 6 features and the accuracy is 0.97. So for every feature, it actually detracts a little bit from the fitness, so the fitness is a little less. These models also give us a 97% accuracy, but they have 7 features, so their fitness is a little bit less. So at the end, the best solution is the one that selected 6 features and actually gave us a very nice accuracy of 97 versus the 91 that we started with. And if you go back to the book or back to the data set, you will see what these features were. If it's like eggs, thorns, how many legs, etc. What is the meaning of those particular features that were selected? So we will continue with other aspects of machine learning in chapter 8. See you there.